Hey everyone, so we are going to talk about our last type of equation today. Let's review the ones we've talked about so far. In this blue cloud, we have our one-step equations, and I added this note right here that one-step equations have one quantity and one relationship. The quantity tells you what the mystery unit is, and there's only one mystery unit, and there's one relationship that tells you the one operation that there is. So that blue cloud has all of our one-step equations. In the two-step equations, there's still one quantity, but then we had two relationships because there were two operations to do. One of the operations was always add or subtract. The other operation was always multiply or divide. So those were a type of two-step equations. The last type of equation we're going to learn about is two variable equations. These are going to have an x and a y. A lot of people like these better though. A lot of people actually find these easier to do than the one-step and the two-step equations. With the two variable equations, there's going to be two quantities because one of them is going to represent the x, one of them is going to represent the y. And then within that subset, you see my pink box is all the possibilities for one-step equations with two variables. Those will only have one relationship. So those can be like y equals x plus 3 or y equals x minus 3, y equals 3x, y equals x over 3. These are exactly the same as the ones in the blue cloud, except instead of the 12, I have a y there, but they're all the same. The two-step equations, I lost my highlighting, let's put that back. The two-step equations with two variables will have two quantities, but these will have two relationships because there's two operations. So those can look like y equals 2x plus 3 or y equals 2x minus 3. They can also look like y equals x over 2 plus 3, or it can look like y equals x over 2 minus 3. These are exactly the same as the ones in the orange cloud, except instead of the 12, there's a y. So there's two mysteries now, two quantities. Feel free to take a screenshot of this so you could refer back to it when it's time to practice. Okay, so when we're talking about two variables and we have the x and the y, one of those is always considered our independent variable and one of those is always considered our dependent variable. Those might be terms you've heard of in science class. Raise your hand if you've ever heard of those. Just kidding, I can't see you. So let's take a look at this next page, which shows the definitions of independent and dependent variables. Let's start with that pink section up at the top with the independent variable. Read along with me while I read. So an independent variable is a variable that stands alone and isn't changed by other variables you're trying to measure. So for example, somebody's age might be an independent variable. I'm going to highlight age. Because no matter what the other factors are, like how much somebody eats, how much somebody goes to school, or how much television they watch, you can't change a person's age. It's independent, it's powerful. Some common examples of independent variables would be time or the letter x. X always goes with independent. So that's something that you have to lock into your brain. X goes with independent. Dependent variables, on the other hand, are changed by other variables, or they depend on other variables. So for example, how tall you are. So let's see, how tall you are, or you could say height. The dependent variable, which is height, depends on the independent variable, which is age. As you get taller, as you get older. As you get older, that causes you to become taller because of how biology works. And then, of course, as you're very old, like your grandparents' age, you might start to get shorter again. But height depends on age. So we're going to practice with this. We're going to look at these little sentence starters and see if we can come up with the independent variable on each one and the dependent variable. The trick I like to use is to start by finding my quantities first. In problem 1, there should be two quantities because remember, two-step equations have two relationships, but two variable equations have two quantities. So what we're working with right here is this green column. There's two quantities for each of these. So I see money is one quantity, weeks is another quantity. These are both quantities, and I don't care about the relationships right now. I just care about the quantities. One of these is going to go in the independent variable category. One of these is going to go in the dependent variable category. Well, it tells me that money is a common example of a dependent variable, and week, which is a measure of time, is a common example of independent. So it kind of did our work for us. So week is independent, and money, or dollars, however you want to write it, is dependent. So what that means is that for each week, that's the independent variable, it's in control, she is given $10. If we give her $20, it doesn't mean that 2 weeks have passed. We have no control over that. But for each week that passes, we can continue giving her $10. So the money depends on how many weeks have passed. All right, see if you could try number 2. Find your quantities, put one in independent variable, put one in dependent variable. Pause the video if you want some time to think. All right, hopefully you've tried number 2. So I see one quantity would be how many apples we have, and another quantity would be cents or dollars. I don't care about relationships for this activity. Well, apples certainly is not one of my common examples, but cents is a common example of dependent variable, that's money. So I'm going to put either the word cents here, or I could put a dollar sign, or I could put money, whatever one you like. That would be the dependent variable, and that depends on apples. So what this is saying is you buy a certain number of apples. That's in control, that's independent, and the money you spend will depend on that. The money you spend depends on how many apples you bought. All right, try number 3. Pause the video if you want some thinking time. Hopefully you're ready to go over number 3 now. So I see minutes and night. Those are both quantities. Now, unfortunately, these are both examples of time. So the trick doesn't really help me here because they can't both be independent. So I have to really think about that. Which one is in control? The one that's in control is the nights. How many nights have passed? Nights. The minutes that she reads is not really set in stone. That's something that she has power over. So you can't read extra and have more nights pass, but the number of nights can tell you how many minutes you could read. The nights are in control. The nights are more powerful. All right, try number 4. Pause the video if you want more thinking time. All right, so I see package and pencils. Neither of these are one of our common examples, so we have to think about which one is in control. The one that's in control is the packages. At the store, you can decide how many packages to buy. You could buy 2 packages or you could buy 6 packages. But you can't walk into the store and decide how many pencils to buy. You can't say you want 13 pencils. That's not an option. The packages are more powerful, and that determines how many pencils you get. The pencils depend on the packages. All right, try number 5. Pause the video if you want more time. All right, so I see tickets and I see money. Money is a very common example of dependent variable. So I know money is going to go there, which leaves tickets to go independent variable. You could have also put people instead of tickets because they really mean the same thing here. The people are equal to the tickets. The money you spend depends on how many tickets you buy, or depends on how many people there are. The last one, give that a try. Pause the video if you want more thinking time. All right, so here it's a tricky one, but the quantities are going to be my two variables. And then y goes with dependent and x goes with independent. So x and y. So we would say that y depends on x. All right, let's take a look at the next page. So problem 1 says in the graph below, which is the independent variable and which is the dependent variable. So we're looking at this top half of the page. Think about what you've learned in science class. This is the x-axis and this is the y-axis. X always is the independent variable and y is always the dependent variable. So look at what those axes are labeled and see if that can help us for later. So the quantities would just be my 2 units. If I look at the things I circled, I see hours and miles. For my relationship, let's take a look at how these numbers, how we got these numbers. I see that 1 gets us 50, 2 gets us 100, 3 gets us 150, 4 gets us 200, and 5 gets us 250. Think about what operation they're using. If you said multiplication, you would be correct. There's no other clues here. They didn't give us the word problem, so that's all we can go off of. Now for independent variable and dependent variable, one of these quantities has to be independent, one of these quantities has to be dependent. Use the x and y clues and see if you could figure out which is which. The independent variable is going to be the one on the x-axis, so that's hours. The dependent variable is going to be the one on the y-axis. So that's miles. And that's all they've asked us to do on that problem. Let's take a look at the next problem. This is a regular word problem, so I think it'll be a little bit easier. So it says Zoe is collecting books to donate. She collects 4 each week. What is the total number of books she has collected each week? Start by circling your Q and R, your Q's and R's. Anything you see, go ahead and circle. You could pause the video if you need more thinking time. For my quantities, I see books and I see weeks. Remember with these 2 variable equations, there's going to be 2 quantities. For my relationship, I see each. And total might be. I think it might just be each, but I'm going to circle total just in case. So my quantities are going to be books and weeks. My relationship, I think it's probably just each. I think total they're just using. But if you put down total as well, I think that's okay. See if you can determine which quantity is independent and which quantity is dependent. All right, well, independent variables I know are usually time, and it's usually X. Dependent variables I know are usually money and Y. But you get other examples too. In this case, I do have a measure of time though. Time would be weeks. So I know that weeks is going to be independent, which leaves books to be dependent. The number of books she has collected depends on how many weeks have passed. The weeks that have passed do not depend on how many books she's collected. You can't force time to change. Time is in control. All right, let's keep going. All right, so let's look at number 3. See if you could pause the video and fill out these 4 right here. Okay, hopefully you filled out those first 4 questions. Let's take a look. It's very similar to the last one, but there's a little bit of a change. Zoe is collecting books to donate. She starts with 2 books, that's a difference, and then collects 4 books each week. What is the total number of books she has collected each week? So my quantities, just like before, are going to be books and weeks. My relationship, I think, starts with, or you could say total. Those would both be addition or subtraction. And then each, so like each week. For the independent variable, I know independent variable usually goes with time or X. Dependent variable usually goes with money or Y. So my independent variable is going to be weeks because that's the time. My dependent variable is going to be the other leftover one, which is books, just like before. Now we have to come up with an equation. For these 2 variable equations, we're always going to start with y equals. And let's see if I can get my equation formats. You might have a screenshot of this already, but I want to bring this into the area we're working in. Okay. Since I had 2 relationships, I know I'm going to be picking one of the equations from the yellow boxes. This is going to be a 2-step, 2-variable equation. It starts with y equals. She starts with 2 books, 2, and then in addition to that, she collects 4 each week. 2 plus 4x. Or you could say y equals 4x plus 2. With addition, you could switch the order. And that is like my first equation type right here. So it's valid. Finally, they ask us a follow-up question. How many weeks have passed if she has a total of 34 books? So they gave us the information 34 books. I have to think about if books goes with my X or if book goes with my Y. My dependent variable is books. And dependent variable has to be my Y. So books is the Y in my equation, weeks is the X in my equation. My equation was y equals 2 plus 4x. I'm going to replace the y with 34. This tells me I want to find how many weeks, which is x, matches up with 34 books. So I have an equation now that we know how to solve. 34 equals 2 plus 4x. Go ahead and solve that equation. All right, hopefully you've solved that equation. I always add or subtract first. So there's a positive 2, I need to get rid of it with a negative 2. 32 equals 4x. Then I have to multiply or divide. Divide both sides by 4. And I get 8 equals x. And to answer the question, it's how many weeks have passed. So my answer is going to be 8 weeks. You don't have to do all the QR less steps. Let's try one more of these together. Do as much as you can on number 4, then come back when you're ready to watch. All right, so let's take a look. For my quantities, I see money and rides. For my relationships, I see additional and per. Now, I know whatever I write for let x has to be the same as what I write for my independent variable, because x means independent. Whatever I write for y has to be the same as my dependent variable, because y goes with dependent. If I look at my key at the top, I see money going to get rid of all these other arrows because I'm going to draw more arrows here. All right. Money goes with dependent, and it goes with y. So I could say let y equals money, and that means the dependent variable is also money. That means my other quantity, rides, goes with x, and independent must be rides as well. X has to match independent, y has to match dependent. And now I have to come up with an equation. So I have to look at my two variable equations in my green cloud. I'm always going to start with y equals $5 to enter the fare, an additional $3 per ride. $5 to enter the fare plus $3 per ride. You could also write y equals 3x plus 5. And that matches my equation type in the two-step box, the first one. This one right here. It's the same thing. And that's all. They don't ask us to